We're going to be looking at absolute value inequalities today. Remember, inequalities are less than, greater than type signs, and how you graph those when it also has absolute value in it. And then we also want you to be able to graph those out as well. Okay, so solving absolute value inequalities, you're going to combine two strategies. One is what we did earlier with graphing compound inequalities. And then also being able to solve absolute value equations. Okay, every absolute value inequality is also then a compound inequality because it's two separate inequalities when you split the absolute value. So first thing we're always going to do, we want to, again, isolate that absolute value. Okay, get that absolute value part of the problem by itself. Follow the same steps you did when it was an absolute value equation, and then you split it up into the negative and positive values. Okay, so here's the new stuff that you need to know. Once the absolute value is isolated, you choose whether it will be an AND problem or an OR problem. And the way that we decide is looking at the symbol. If it's either one of the two greater than symbols, either greater than or greater than equal to, then it's going to be an OR problem. Okay? If it's either of the two less than symbols, less than or equal to, it will be a AND problem. Okay? And then you're going to graph kind of the intersection or what's in between those problems. One way to kind of remember that is great or, kind of sounds like the end of this sounds like great or, and then less than and kind of sounds like and. So that's kind of a way that you can know which one it's going to be. All right, so here's the first one we're going to look at. Solve this out. Because the step one, we want to isolate the absolute value, get that by itself. So here that means adding 10 to both sides. So now, and that's the exact same thing we did if it had been an equal sign here instead of inequality. All right, next step now, split the inequality up. Okay, and here's where you're going to want to make a decision. Is it an AND or problem? Well, this one's greater than symbol. Greater or kind of sounds like or. So this one's going to turn into an or problem. So we end up with two things. One, that this 2x minus 3 can be greater than 5. Or that this same inequality, okay, could be less than the opposite of that value, negative 5. Because remember, absolute value means distance from 0. So we got to have the positive value, which is over here, but also the negative value. And because absolute value is distance from 0, if we got 5 out here, and that's the points that are going to be bigger than 5, we also want the other side that are the same distance away. Well, that would have to be going out that way. So that's why we got to flip the inequality sign around. All right, now we want to solve these two. Okay, so solving this out, just be like solving equations again. You do all the same type of steps, except if you divide or multiply by negative, then we got to flip the sign. So here, divide by 2, we get that x is greater than 4. Or now we got to solve this other one here. Looks like same solving steps. Add 3, divide by 2. Don't need to flip the sign because we're dividing by a positive 2 here. And we get that it also could be less than negative 1. So we want to graph both these out, greater than 4 or less than negative 1. On your graph then, make sure you label so that you have those points. So somewhere here we want both are 2 points. Less than negative 1, So we want to go there. It doesn't have the or equals to, so we want to keep an open circle. Less than is going to be the points going to the left. Greater than 4, so 4 is out here. Again, don't fill it in because it's just greater, not greater than or equal to. That would be the points going to the right, the points greater than 4. So that's what our graph should look like on that one. The or ones, your answers are going to be here or here, one of the two places. Okay. All right, second example on the other side, looking at these special situations. So just like when you were learning absolute value equations, if you isolate the absolute value and it's greater than or less than a negative number, it's one of those special situations. So what we looked at before with the equals, if you're equaling a negative number, absolute value is distance. Distance can't be negative. So there's no solutions to this one because anything in that absolute value is going to come out positive. We can't have a positive equal to a negative. On B, absolute value, remember this is going to come out to be positive. It's going to come out to be a positive number. Can we have a positive number less than a negative number? No. So this one's also a no solution situation. We can't have a number that's a positive number less than a negative number. The last situation, again, absolute value, its distance, it's going to come out to be positive or 0. Can we have a positive number or 0 greater than a negative number? Yes, this situation is going to work. Whatever this absolute value is going to come out to be positive. So if we have a positive bigger than a negative, that's going to be true no matter what we plug in there for x. And so the answer for this one is that this is always true for any x. And so what we say here is the answer is all real numbers. Any number for x is going to work in here. So x can be any number or all real numbers. Okay, so let's just try some more of these solving ones here. This one, 5x minus 10 less than 15, isolate the absolute value. Already done for us. There's nothing else on that left side besides our absolute value. Now we're going to split it into two problems. So 5x minus 10 has to be less than 15. This one's a less than and. So this one's an and one. And 5x minus 10 could also be greater than the opposite of that, negative 15. So we flip the sign and opposite number. So now go through and solve. Add 10 and divide by 5. And we get that x can be less than 5. And it also has to be true with what's over here. So if we add 10 here, we get negative 5 divided by negative 5. And it also has to be greater than 1. So these ones now both have to be true. So if we wanted to, we could link this up into a compound inequality that x has to be less than 5 and also greater than negative 1. And we'd write it like that as a compound inequality because if we were just to switch these two things around on the second one where it's pointing at the negative 1, notice how that is saying the same thing there. So this compound inequality says all the numbers less than 5 and greater than negative 1. So when graphing this one, again, make sure that you can get those points on your graph here. Okay, looks like open circle at both. Okay, less than 5 is going that way. Greater than negative 1 is going that way. It's all our points shaded in between here should be the ones on the graph. Because all the points have to be less than 5 and greater than negative 1. So it's got to be in between those two values. Okay, on this one, same thing, okay, less than, this is an and one. And so we know this has to be less than 14. And the same thing, the absolute value could be opposite sign greater than the opposite of this value, negative 14. Solve them both. Here's an example though of one. When we divide here by negative 7, that means anytime you're dividing by a negative, we're going to have to switch the direction of the sign. So greater than negative 2, and if we do the same thing over here, divide by the negative 7, we get x. Negative divided by negative is going to be positive 2. Divided by a negative again, got to switch the sign. So this one's saying less than 2, greater than negative 2. You can write that as a compound inequality, less than 2, greater than negative 2. So it's all the values in between negative 2 and positive 2. On the graph, okay, again, make sure you can get these on here. Be open circle at both. Less than 2 is going that way. Greater than negative 2, that's going to the right. We want them all shaded in between. All right. For C, why don't you pause the video, try that one out yourself, see what you get. All right. Let's see what you add. Remember, isolate variable first. So we want to add 9 here. That would be 36. Now we got to get rid of this 4. Hopefully you did not distribute here. Remember, absolute value looks like a parentheses, but doesn't do the same thing. You can't distribute. So the way you should have moved that, it's being times here. Opposite of times is to divide. Make sure you didn't minus. It's not being added to that. You got to divide. And so to isolate the variable, we get that this absolute value has to be greater than 9. Okay, once you're to that point, now here's where you want to split it up into your 2. So you get that 3x minus 6 could be greater than 9. Greater, this is an or one, or that this 3x minus 6 has to be less than the opposite, negative 9. Solve these ones out, and you should have got that x is greater than 5, or solving this other one, you get that x is less than negative 1. Graphing them out now, what it's going to look like. You have open circle at 5 going to the right, open circle at negative 1 going to the left. So the points, the answer is either here or out this way over here. All right, if you get one like D that has a fraction, goal still doing the same thing, isolate variable first here. So minus 11 part is not too tricky. Here's where we get into this fraction. What do we do with fractions again? You want to get rid of the 4. It's being divided. Opposite of dividing by 4 is to multiply by 4. So we can times both sides by 4. So now you got 24 out here. Now it's being times. So divide by 3. And you could do that in one step too. If you multiply by the reciprocal, it would do the same thing. So now we've got our variable isolated. This is a less than 1. This is going to be and then, less than, and. So if you write out the 2, it's going to be that 8x minus 16 has to be less than 8, and 8x minus 16 is going to be greater than the opposite, negative 8. Solving them out. Pretty straightforward. Divide and you get less than 3, and also solving this other one, we get that x has to be greater than 1. So now graphing them. Okay, this one over here, greater than 1. That's going that way. Less than 3. That one's going that way. Looks like all the points in between. If you're writing this as a compound inequality, less than 3, greater than 1. It looks like that. All right, on E here, okay, again, always isolate variable first. So add 35 to both sides. And now we got greater than 30. Okay, undo this steps, times by 4 to get rid of the division. Now you got 120 over here. This is multiplying, don't subtract here, so you got to divide by 3 and don't distribute either. So now you got 2x plus 4. Absolute value of that is greater than 40. Okay, now we want to solve this one out, see what you get. Split it into 2. This is greater, so this is going to be an OR one. So you get 2x plus 4 is greater than 40, or 2x plus 4 less than or equal to opposite of that, negative 40. Solve them out, and so here we got 2x greater than 36, divide, and x is greater than or equal to 18, or solving other one, minus 4, that's going to be negative 44, divide by 2, negative 22. If you get a bigger one like this, remember you could always make your graph by whatever you want. So on this one, you could maybe skip by like 6s, or maybe 6s won't work, but something bigger. But just kind of graph quickly here, you got negative 22 and 18. Greater than this, and this one would get filled in because it's got the equals to, so greater than 18, or less than or equal to, so another filled in one here, less than would be out that way. So it'd be all the points there. All right, last one. Again, why don't you pause the video and try this one, see what you get. All right, let's check it out. Isolate variable first. This one, a little bit different than the last one. Don't plus 3 here yet. Everything's over this 4, so first step on this one to isolate should have been timesing by 4 to get rid of that. Okay, once you multiply that out, you're going to get 72 here. Now, here, I forgot the minus 3. Next would be to add 3 to both sides. Okay, got to add that first, making that 75. Now, last step, again, don't distribute, don't minus here. This is being times. Opposite multiplying is to divide by 5. That's the way to get this one isolated. Now, that turns out to be 15. Now we can go through and solve by splitting this up. Less than and, it's an and one, so you got 10x plus 5 is less than or equal to 15. And the other part here, that 10x plus 5 greater than or equal to negative 15. Solving these, you get less than or equal to 1, and the other one greater than or equal to negative 20 when you subtract 5, divide greater than or equal to negative 2. That's what we want to graph here. If you write this one out as a compound inequality, we're going to get that x should be less than 1 or greater than negative 2. Now graphing it, would look something like this: closed in, less than this one, greater than this one, everything in between.